After introducing confidence intervals and showing how to calculate them, there were several exercises. You were asked to use the same data to find other confidence intervals. Let's take a step back and try to understand confidence intervals a bit better. Here is a graph of a normal distribution. You know where the sample mean is? In the middle of the graph. Now, if we know that a variable is normally distributed, we are basically making the statement that the majority of observations will be around the mean and the rest far away from it. Let's draw a confidence interval. There is the lower limit and the upper limit. A 95% confidence interval would imply that we are 95% confident that the true population mean falls within this interval. There is 2.5% chance that it will be on the left of the lower limit and 2.5% chance it will be on the right. Overall, there is 5% chance that our confidence interval does not contain the true population mean. So, when alpha is 0.05 or 5%, we have alpha divided by 2, or 2.5% chance that the true mean is on the left of the interval and 2.5% on the right. Okay, great! Using the z-score in the formula, we are implicitly starting from a standard normal distribution. Therefore, the mean is 0. The lower limit is minus z, while the upper one, z. For a 95% confidence interval, using the z-table, we can find that these limits are minus 1.96 and 1.96. That's exactly what we did in the previous lecture. Finally, the formula makes sure we go back to the original range of values and we get the interval for our particular dataset. Okay, what if we are looking at a 90% confidence interval? In that case, the interval looks like this, and there is a 10% chance that the true mean is outside the interval. Actually, 5% on each side. This causes the confidence interval to shrink. So, when our confidence is lower, the confidence interval itself is smaller. Similarly, for a 99% confidence interval, we would have a higher confidence, but a much larger confidence interval. Let's see an example, just to make sure we have solidified this knowledge. I don't know your age, dear student, but I am 95% confident that you are between 18 and 55 years old, based on the fact that you are taking an online statistics course. That's not much information to begin with. Plus, I don't have any information about the age of any of the students, hence the wide interval. Okay, so I am 95% confident you are between 18 and 55 years old. Also, I am 99% confident that you are between 10 and 70 years old. I am 100% confident that you are between 0 and 118 years old, which is the age of the oldest person alive at the time of recording. Finally, I am 5% confident that you are 25 years old. Obviously, this is a completely arbitrary number. As you can see, there is a trade-off between the level of confidence and the range of the interval. 100% confidence interval is completely useless, as I must include all ages possible in order to gain 100% confidence. 99% confidence gives me a much narrower range, but is still not insightful enough for this particular problem. 25 years old, on the other hand, is a pretty useful estimate, as we have an exact number, but the level of confidence of 5% is too small for us to make use of in any meaningful analysis. There is always a trade-off which depends on the problem at hand. 95% is the accepted norm, as we don't compromise with accuracy too much, but still get a relatively narrow interval. Great! After this short clarification, let's carry on with more statistical problems. Thanks for watching.